I'm going to talk again, guys, about fundamental theorem of calculus, but part 2 today, and this part 2. Okay, which states that if we have an area under the curve from two closed points or closed interval a to b, this area can be defined using the definite integral a equal antiderivative from a to b f of x dx. You have to write that a prime of x is equal to f of x, and also I have to know that a of a equals 0 and a of b equals a. What does it mean by a of b equals a? And the distance from a to the distance of the area from a to b all is a, and the distance from b to what? From a to b is all a. Okay, so when I say a of b equals a, why this? Because when we substitute here equal f of what? F of b minus f of a. F of b minus f of a. You can prove that f of b minus f of a is equal to a. Here, how to prove that f of b minus f of a equals f of what? Equals exactly the area. Because we can say that f of b equals f of b plus c, or a of b plus c, and minus f of a. And we know that this f uppercase is equal to what? Ax plus c from the indefinite integral. We know that this f uppercase of a or b equals equals ax plus c. So, and it gives you the area under the curve plus a constant. So here we will cancel out c with c, and we still have a of b minus a of a 0, and we still have a of b. A of b already part of a, so we proved now that a equals f of b minus f of a. No need to know the proof, but I just tell you about it. Okay, why f of b is what is b? Why a of b is b is a? Because if you have any value for x here between a and b, this value x is changeable. And when the x increase, when you move this x right and left like this, you will find that the area also increase. So when this x is exactly at a, the area is 0. And when this x here is moved till reach b, or exactly on b, you will find that the whole area is exactly equal to a. The area moved with you and exactly is a. That's why a of a equals 0 and a of b equals a. Yesterday we said in the important issue you have to know from the fundamental theorem of calculus the connection between integration and differentiation. And the first part states that if is continuous on the closed interval ab, and f uppercase is the antiderivative of f, so the definite integral from a to b, the definite integral from a to b of f of x equals f uppercase of x uh, plus c in the definite, and then evaluate from a to b by substituting b first. So we have f uppercase of b minus f lowercase of a. In the next example, we will use these guys to evaluate simply the integral from 1 to 2 of x dx. Yes, I'm gonna do this question easily by adding 1 to the exponent. Find a function that is an antiderivative of x, which is f uppercase, so which is x squared over 2. So f uppercase is x squared over 2, which is the antiderivative of this function x. And then evaluate, make a bar like this or a vertical line to each like this one, and evaluate from 1 to 2 لو عادي زي ما نشتغل, which is 4 over 2 minus, and substituting 1, we start first by plugging 2 and then plugging 1. So your answer is 2 minus half, which is 1.5, which is 3 over 2. So your area under this curve x is 3 over 2 from 1 to 2. That's it. This is the first example. Also, you can here graph We have here is x, and we have here is what? Y. And when I graph x, so this is a line. This line is passing through 0, 0. Here, 0, 0. We have 1, 2, 3, 4, 5. So we have here 1, 2, 3, 4, and what? And 5. Here is 1, 2, 3, 4, and stop. Okay, 0, 0, we have 1 and 1, we have 2 and 2, we have 3 and what? And 3, we have 4 and 4. When you connect here these points, no, not like this. So not accurate. So when we connect the points, yes, this point should be up here. No problem. When we connect here and find the area from what to what? From, pay attention, from what? From 1 to 2 only. هنا. من 1 till 2 only under this curve. This shaded green area is our goal here, is our area we have to find under this line, y equals x. Okay, so simply it's a rectangle. If we do a rectangle here, okay, if we do a rectangle here, so some of the area is still what? Not evaluated. And if we do a rectangle from here, some of what the area of the rectangle is above the curve, so we have overestimation or underestimation. It's better to take what, guys, here? It's better to take a midpoint between 1 and 2 and then multiply its f by what? Here is a midpoint عشان يبقى بعض الريكتانجل above and some of the rectangle is below, so the area is above is the same as the area below, not evaluated. So let's do the area of what? area of, ومن الأول خلاص ممكن نعملها area of trapezoid تظبط معانا برضه. يعني we cancel this one and we have now like a trapezoid, yes, but we don't know here what's the, we know that this one is 1 and here is 1 and here is what? Is 2. So base 1 is 1 and base 2 is 2. Where is the first base? Here. The first base is 1. What's the second base here? Which is 2. And multiply by the height. The height is here, the distance between 1 and 2. So this all over 2 multiplied by the height, which is 1. The height is here, guys, which is 1. So h equals 1. And this is the first base, مثلا, and this is the second base, B2. And we know that the area of trapezoid is B1 plus B2 over 2 times height from geometry. So we have 3 over 2 times 1, gonna give us 3 over 2. So this is how to use geometry to find your area. And this is how to use definite integral and fundamental theorem of calculus to find your area under this curve x. Okay, this is our first example today. Any question? Yes, also we can approximate the area by using the Riemann sums or by using the mean value theorem of integration. By taking, as I said for you, the midpoint here between 1 and 2, which is 1.5, okay, and then multiply it by the height. This is the height now. We will find here f of 1.5. We will find what? One more way is to find the area is equal to, لو أخذت midpoint here, خلينا نغير الكلر. Yes, this one. لو أخذنا halfway here between 1 and 2, like 1.5, yes. And then make a line like this, then find the height. This line is the height now. What's the height? Yes, this height is a rectangle. Okay, what is the height of this rectangle? It's f of 1.5. f of 1 and 1 over 2 multiplied by the base with delta x. What's delta x? Which is 2 minus 1. Delta x represents the base of this rectangle. And we know that area of rectangle is equal to base times height here. So the base is represented by delta x and the height is represented by the value of f of 1.5. f of 1.5 is equal to, I'm substituting in the function itself, because the function is x, so substituting 1.5 for x is 1.5 يعني 3 over 2 برضه أو أكتبها 1.5 and delta x is 1 and also it's 3 over 2. So when you approximate the area by using the midpoint is 1.5, which is the most accurate one, exactly the same as your integration and geometrically. So here by using geometry and here by using the midpoint formula, okay, and here up by using what? Definite integral. Any question? You can do this. What? Any questions, guys?
No, Mr. Thank you.
Okay, next page, we have example 2. In example 5 of section 4.4, we used the definition of area to show that the area under the curve y equals 9 minus x squared over the interval 0, 3, 0 and 3 is 18. In section 4.4, كانت الarea under this curve by using the definition of area, it was 18 square units. We can now solve the same problem much more easily using fundamental theorem of calculus. Okay, how? Who can do it? The first part of fundamental theorem of calculus states that we can integrate here this function 9 minus x squared from what to what? From the closed interval 0 to 3 dx. First of all, check that 9 minus x squared, is it a continuous function or not? Sure, it's a continuous function because, it's a parabola opens down, right? Opens down, yeah. And if we graph it quickly, what's gonna happen here? I'm gonna move 9 units here. I think it's gonna be like this, صح؟ بس هو بيسأل عن from 0 to 3 only. So we will take only one part of this function. ما علينا. المهم هنعمل integrate by using fundamental theorem of calculus, which is f uppercase of 3 minus f uppercase of 0. So I have to find first an antiderivative of f. This all is f of x. يعني 9 minus x squared is f of x, small or lowercase f of x, which represents the function itself. But f uppercase of x represents the antiderivative. The antiderivative of what? Of f of x. So يعني integrate يا شباب، ده معناه. When you integrate 9, gonna give us 9x and then evaluate it from 0 to 3 or leave it at the end مرة واحدة. Okay, and then minus integrating x squared gives x cubed over 3 and then evaluate this all from what? 0 to 3. From 0 to 3 equals. Substituting by 3 only and omit the 0 since both terms including the x, so at the end will be 0. No need to do it. So 9 times 3 first. I'm going to substitute 3 into x minus 3 cubed and this all over 3. 9 times 3, it's simply 27. We start by the uppercase of the integration, 3 first, and then 3 cubed, which is 3 by 3, 3, which is 27, and this all over 3. So we have 27 minus 9, because 27 over 3 is 9. 27 minus 9 gonna give us 18, equals 18, which is the same as the upper what answer. Where is it? Here, by using the definition of area. Definition of area, which is in section 4.4 by using definition of area. Now we are using the fundamental theorem of calculus to find the same answer by using the first part of fundamental theorem of calculus. It's 18, exactly the same. Okay, I'd like guys to switch on the Desmos graphing calculator to show you how to graph 9 minus x squared and where's the area between 0 and 3. So give me only 1 second. Here is Desmos graphing calculator. I'll go to Google and then I'll share for you my screen. Yes. Okay, as you see here, guys, the function is 9 minus x to the power of 2, x to the power of 2, x squared. Okay. X to the power of 2, here is x. Write it again. No. Here is x, no. Yes, x to the power of 2. Here is the function. Here we are. Yes. So as you see, guys, here is the parabola, and we raised up 9 units. So that's why I switched on the Desmos, because I already moved the graph 9 units right, and this is not correct. We have to move it up 9 units, which is the value of k. We have to minimize شوية ونروح نشوف فين من 0 to 3. From 0 حلو till 3. Only this area. From 0 to 3. 3 is an x-intercept. If you move here, guys, you'll find 3 and 0. 3, 0, and 3 is an x-intercept. So from 0 to 3, we would like to find the area under the curve and bounded by both y-axis and x-axis. So here is this part. So let's switch here, guys, to my slides. Listen, نشوف. So this graph نكنسله. كنت عملت 9 units right. لا. I'm sorry. We have to move up 9 units لأن هذه k. نطلع كده 9 units وننزل نعمل intersect مع F3 وهير 0. طبعا أنا مش محتاج negative part of the parabola because we are only studying the area between 0 and 3. So let me shade only our goal region. We would like to find its area. It's here. This part, this blue shaded region. Yes, this one, guys. So from 0 to 3, we would like to find the area. طب هو قال لي in section 4.4 احنا استخدمنا definition of area to find the area under the curve of y equals 9 minus x squared. Okay, so who can solve with me here this problem by using the definition of area and finding here the area of this function 9 minus x squared? Yes. Who can approximate the area? Who can find the area by any way? Yes. So like a half circle here? No. So we have to divide this area into smaller and smaller rectangles and then find the summation of all areas of the rectangles we can divide and then add up by using a sigma notation and Riemann's sum. Yes. So who can find it here? What's the area? The area is equal to the summation of delta x approaches 0, the summation of, let me say k or I حسب الكتاب قال k equals 1 to n of delta x times f of what? f of xi, or xk. Okay, so what's delta x? Delta x here represents the width of each subinterval, right? We are here from 0 to 3. خالد الشاعر. Complete from 0 to 3. Let us divide this area into 4 subintervals. So to find here 4 subintervals, to find delta x, we have to subtract b minus a over n. So we have 3 minus 0 over n. It's 3 over 4.
طبعا مش فاهم شو بنسوي.
Yes, عشان انت داخل متأخر. احنا هنا في الكويستشن نجيب الاريا under this curve 9 minus x squared as I graphed it here at the left and the x-axis. This yellow shaded region. And to find it we have two ways. In section 4.4 هو بيقول لك انا اشتغلت وجبتها 18. Now حسب الليسن اللي شغالين فيه Fundamental Theorem of Calculus would like to find it and you will find it that it's more easily to find it. It's 18 by integration يعني by definite integral. In section 4.4 he found the area or approximate the area that it's 18 by using the definition of area وكده. أنا بعمل اشتغل الكلام ده دلوقتي. Because the distance is between 0 and 3, we have to divide this distance between 0 and 3 into smaller rectangles, into 4 parts مثلا 4 rectangles. اوكي
طيب
طيب
فالرول هي التحديد المستخدمها
هذه الرول represents delta x اللي هي طبعا ايه delta x the width of each subinterval يعني the distance between each number and the successive number. يعني let's say 0 انا قلت 3 over 4 by using b minus a over n. انا قررت ان انا divide this distance between 0 and 3 into 4 rectangles. So b is 3, the terminal point, and the initial point is a, which is 0. 3 minus 0 over 4 gives 3 over 4. يعني المفروض امشي 0 وبعدين 3 over 4. Okay.
طيب
0.75 and then add up more 3 over 4.
يعني 1.5 بعدين 2.25
1.5 and
2.25
2.25 and then 3, right?
هذا هو الحكي.
حلو. تعال بقى مستر. What's that? We have delta x which is here. What is f of each point here? ليك طريقتين، ممكن تشتغل على الليفت وممكن تشتغل على الرايت. And let's use the left one.
تمام.
يعني the left rule. I will take the 0 and 0.75 and 1.5
1.5
and 2.25. So my area now is equal to delta x اللي عرفناها خلاص 3 over 4 أو 0.75 multiplied by f of the first point which is 0 plus f of 0.75 yeah plus اللي هو the sum of all heights we have.
الملخص كلهم.
No, not all, till 2.25 only.
مو 3 يا مستر قصدي.
1, 2, 3. And the fourth one?
2.25.
Yes, I took 0, 0.75, and 1.5, and f of 2.25. And then calculate this all in your calculator. 3 over 4, f of 0, what is the function? Is here. لا, الفانكشن نفسها 9 minus x squared, so it's 9.
اوكي it's negative minus خلاص 9 صح. معلش.
اوكي يلا 0.75 سكويرد يعني اعملها بقى على الكالكوليتر 9 minus 0.75. Here is 9 minus 0.75 times 0.75. It's 9, it's 8.43 or 44. Okay, then plus 1.5 times 1.5, it's 2.25. Let me write it in negative, and then plus 9, it's 6.75, right? Okay, evaluate with me, guys. Make sure. When it's 2.25 times 2.25, it's 5.06. We need to make it negative, and then at 9, it's a 3 point. Is it correct? 3.93. When we add up all 3.93 and 6.75 and معاك 8.44 تقريبا plus 9.
بس ليش ما بنعملها
by 0.75
يعني الكلوزد فورم بتصير 8.5 بتصير 8.43 بنعملها 8.4
wait
3.93
يعني rounding
اسهل يعني
approximation اصلا يبقى your answer معايا تقريبا طلعت in all 21.1 which is the overestimate وكده. You have to use the midpoint
9 plus 8
you have to use the midpoint وكده and we have to use the midpoint will be more accurate. This is overestimate. The exact area it should be 18. هنا overestimate because we used the leftmost endpoints 0, 0.75 و 2.25 and so on. لو اخذت الميد بوينتس between 0 and 0.75 وكده يطلع معك accurate شويه تنزل معك تقريبا ل 18 point something. Okay, this is by using section 4.4 وبالاحمر هذا by using what fundamental theorem of
calculus. مستر
yes
هلا هو كله واضح بس بدي افهم شغله واحده.
yes
انت ليش عملت هايلايت بالذات على المكان اللي على اليمين يعني من 0 ل 3 عشان اعطينا من 4 ل 4
over the closed interval 0 to 3
0 3 خلاص تمام
from 0 till 3. Next example 3, letter A, no problem. Find the area under the curve y equal cosine x over the interval 0 to 2 pi. هذا الفيجر 4.6.4. this figure at this figure below. Okay, and then make what? A conjecture about the value of the interval from 0 to pi cosine x dx, and confirm your what conjecture using what? The fundamental theorem of calculus. So letter A, who would like to find the area under this curve from 0 to 2 pi? Raise hand,
مستر
please.
هيا أول وحدة.
Yeah, what's the area from 0 to 2 pi of this function cosine x under this curve, the x-axis?
We need to نعوض.
We have to find the area under the curve. Where's the area under the curve? And here, this area, we can name it area 1, and this area 2. And also, we take what? Over the interval 0 to 2 pi, pi over 2.
Yes, I mean مو بنعمل f0 plus pi over plus f pi over 2.
وعايزها تل pi over 2 يعني only this area, this shaded area.
Yes, we do f0 مثلا نفس ما سوينا بالقبلها f0 plus f pi over 2.
Okay, we can find the area by any way you want, guys. If you would like to find this area from 0 to pi over 2. Okay, of cosine x dx, which is, what's the integral of cosine? Is negative sign? No, positive sign. From what to what now? From 0 to pi over 2. And then substitute. Find first the sine pi over 2 minus sine 0. Don't say that 0 in the lower boundary, so I'm gonna omit it. No, not on the 0 right now, guys. Then if you trick function. So sine 90 is 1 minus sine 0 is 0. So your answer is 1. So the area under this curve cosine x and between 0 and pi over 2 is 1. This shaded region is what? Is 1. Okay, now let's find here, guys, the letter B. Let's find here what the value of the integral from 0 to pi, from what to what? 0 to pi of the function cosine x dx. It's the same. The integral of cosine is positive sine x, positive sine x, but now from 0 to pi. So your answer now is sine pi minus sine 0. Yeah, sine pi equals 0. Okay, and
sine 0 0.
0. So the area here is what? It's 0.
تمام.
So from 0 to pi is 0. Why? لأن مستر area from 0 to pi over 2 is 1. And the area from pi over 2 to pi is negative 1. So let's find here, guys, the area. خلينا نروح نجيب الاريا من pi over 2 till pi of cosine x dx.
طيب بنغير بتصير
sine
x
from pi over 2 to pi. تعوض تكون
بتصير ساين باي اوفر 2 اللي هي 0 اللي هي 1 عفوا.
ساين باي الاول، ساين اللي فوق الاول minus ساين باي اوفر 2 which is simply equal to sine pi
يا مستر هي
0 minus sine pi over 2 which is 1. So
1.
my final answer is negative 1. So in the area from 0 to 1, from 0 to pi over 2 is 1, and the area from pi over 2 to pi is negative 1, they're gonna cancel each other. So the area up here is 1, and the area down here is negative 1.
Negative 1.
But you can write also here in the area from 0 to pi, the area from 0 to pi of the same function cosine x dx can be written as the sum of the area from 0 to pi over 2 عملها stations of cosine x dx plus the area from pi over 2 till pi of cosine x dx. When we add up these two areas, 1 plus negative 1, okay, directly is 0. ففعلا it's 0. By using also the fundamental theorem of calculus, which is part 1. Okay.
تمام يا مستر.
Any questions, guys? شبابس.
لا بس أنا بدي أفهم مستر، أنت آخر شيء عملته تبع اللي 1 plus negative 1 equals 0.
اللي هي the whole area, the whole part. Let me change the color here. ناخذ مثلا this green.
يعني من
From zero.
كامل من 0 لباي.
From 0 till pi.
باي تمام.
Can be written as two parts. The integral from 0 to pi over 2, and then the integral from.
بنعملها بارت واحد.
Two parts يعني. كبارت واحد is the same as two parts.
Two parts.
Or the sum of two parts. So
هو نفس الجواب بالأكيد.
1 plus negative 1 is what? Is 0.
0.
طيب,
تمام.
1 minute please. Yes. Which page here this example? Do you have your books? Yes, it's here. In letter B, guys, the given integral can be interpreted as the sign, the area between the two, between the graph of y equal cosine x and the interval 0 to pi وكده نفس الطريقة, okay? The same. طيب, no new information in this question and this answer. So it says letter A and B. Now we will talk about what. Leave this right now, guys. We'll do it in the last period. أو عادي تعالى ناخده أحسن. This is the relation between the indefinite and definite integrals, that they are both the same. Okay. As you see, guys, in the previous examples, all without plus c, right? But in definite integral, we should add c, which is constant of integration. Okay. In general, when applying the fundamental theorem of calculus, there is no need to include a constant of integration. Why? Only because it will drop out away anyway. كده هتكنسلها. So, for example, the definite integral from a to b f of x dx can be as f uppercase of x, which is the antiderivative of f of x, plus c from a to b. Okay, and then substituting, we have to write it as f of b plus c minus f of a minus c. We can cross out c with c and we still have f of b minus f of a. So no need to write the c. This is the relationship between indefinite and definite integral. Example 4, me ask Faris Matar, yes? What's the answer here?
Yes, mister. Okay. X to the power 2 over 3, x to the power 3 over 2.
What?
The integration is 2 over 3.
2 over
x
3.
To the power 3 over 2.
Hello, x to the power of 3 over 2. And then evaluate it from 1 to,
Yes.
1 to 9.
And replace the 9.
Yes, so we have 2 over 3 and 9 to the power of 3 over 2. Hello. Minus 2 over 3 and then replace the 1 here to the power of 3 over 2 and then calculate it. 9, it's 3 cubed. You can take first the square root because power half, which is 3. 3 cubed is 27. 27 divided this 3 gives 9. 9 times 2 is 18. 1 to the power of anything is 1 times 2/3 is 2/3. 18 minus 2/3, it's what? 54 over 3?
52 over 3.
Now the answer is 52 or 52 over 3. We will stop here, guys, and inshallah we will continue in the last period. In the last period, we will complete these examples and also here, example 8, and we will study tomorrow, inshallah, the mean value theorem. In the last period, we will talk about the second part of the fundamental theorem of calculus. In the last period, the 7th period, بناخذ الافريج ريت اوف تشينج، بناخذ اللي هي الاكسرسايزز.
طيب يا مستر.
يا شباب.
طيب مستر نراك اخر حصه.
باذن الله. السلام عليكم.
السلام عليكم.